The last chapter in this book, we are talking descriptive statistics, okay? So that's statistics that are going to tell you what kind of numbers you have. So the ones you are familiar with are the mean, the median, and the mode. Hopefully you're familiar. Median, remember, is the middle. The mean, you add all the numbers up. It's kind of a pain. You add them all up and divide by how many you have. And then the mode is the one that happens the most frequently. Okay, the mode is the only one of those that you may not have, or you may have more than one. Now, the idea of the mean, the median, and the mode is it's supposed to give you an idea of where the middle of your data is. So depending on what kind of data you have, depends on what kind of number you use. Okay, so let's look over here. We already know how to find mean, median, and mode, but take a look at this data, and it says, does the mean or the median best describe or best represent this data? So first of all, let's find both of them. To find the median, we have to put them in order, least to greatest, and find the middle number. Okay, so the smallest number I'm pretty sure we have is 209. So 209, then we have, I'm going to mark that, then we have, I believe, 219, right? 219, then we are at 256 and 257, two really close ones there. Then 277, then, oh, they are in order, just descending order. Look at that. It took me that long, halfway through, sorry about that. 293, 296, 302, 312, and 749. Okay, so our median, if we have 10 numbers, isn't going to be one of our data points. It's actually going to be between them. So the middle two are right here. So when we have two middle numbers, remember to find the median, we add them up and divide by 2. So I'm going to add 277 and 293, and then go ahead and divide by 2. So my median, which I'm going to represent by MED so that you know it is 285. All right, now our mean, let's add all these stinkers up. We got 10 of them. So 209 plus 219 plus 256. If you're faster than me, that's awesome. Just be very careful because it is very easy to make a mistake as you're punching all of them in. 749, okay, and divide by 10 because we have 10 of them. Oops. Back, I'm getting a syntax error. 10. So my mean is 317. Now, which of those two numbers is really a better representation of our data? Take a look at our numbers. Take a look at where 285, we got 209, 219, 256, 257, you know, and so on and so forth. Look at this number right here. That number is an outlier. It is very much an outlier. But take a look at where our mean falls in our data. It is bigger than every single number we have except one. So this is what I'm going to tell you. When we have an outlier, you want to use your median. It better represents your data than your mean because an outlier affects your mean so much. If it's up here, it pulls your mean way higher. If it's really, really low, it pulls your mean way lower. So it's not a good representation of the middle if you have an outlier. So our median, and my explanation, because the mean is skewed, just means it pulls it one way by the outlier. Okay, when you have an outlier, you don't usually like your mean to represent your numbers. Okay, you're going to want to use more of a middle number, and your median is exactly that. Okay, central, so those are all measures of center. Okay, but sometimes one is better than the other. So we don't talk about it in here, but I'm going to talk about it. When do you think we would use the mode? Remember, in this case, we don't even have a mode, so obviously you don't use the mode when you don't have one. But when you use the mode is when you have lots of repeating numbers. So maybe your data are all single-digit numbers and you have lots of repeating ones. That is the time where your mode is probably going to be your best option. You use a mode to represent the middle. Very, very rare. Okay, so it's usually the median if we got an outlier, or the mean if you have a lot of the same numbers. Like a lot of the same numbers, then you would use the mode, but that is very rare. All right, let's move on. Slide number 3, measures of center and variability. So how our numbers vary, how they change, where they move. All right. Obviously, center and variability, we're going to use mean, median, mode, and all of these things when we have one variable, univariate. Remember, scatter plots are used when we have two variables, bivariate data. This is just one. All I got is one single number. In this example, I'm talking ages of people at a movie. These are the ages of people sitting at in one row in the movie theater. All right, and they want you to find the mean, the median, the mode, and the range. Now, I am not going to take the time to do this because I think you could probably handle that. Remember, mean is adding them all up and dividing by the total. The median, you have to put them in order, smallest to least. So it would be 15, 16, 19, 19. There's your mode, right? 24, 30, 33, and 56. All right, and given this, that 56 looks like a pretty good, maybe an outlier. So your mean might not be your best representation of this data either. All right, but there I put it in order. You should be able to find your median and your mean, your mode. I am not going to help you with that because, folks, you've got it. I will remind you, though, range. We just assume you guys remember that. The range is how spread out they are. We find that by taking the largest number, 56 minus 15, minus the smallest number. So our range is going to be 41, right? 41, because their spread between the biggest and the smallest is 41 numbers. So that's our range, how big it spreads out, okay? Mode is 19. Median, 1, 2, 3, 4, 5, 6, 7, 8 is going to be between those two, which you can find, add them up, divide by 2, and mean, you can find that as well. Okay, now we are going to move on. That is mean, median, mode, and range, something we've talked about, something you've been doing for a couple years. The 5-number summary is something else we do with univariate data with only represented by one number, like the ages or like the scores, all right? Quantitative data, it can be measured. It's going to be numbers, a set of data, and we can divide it into 4 equal parts. Now, when we put numbers least to greatest, that's the hardest part, line them up, smallest to biggest, and then we find the median. Okay, in this case, we've got an even number of data, so our median would be right here. Our median splits it into 2 halves. Okay, then we actually come to the bottom half and we find the middle of those. So what happens, then we find the middle of the bottom and the middle of the top. And what happens is we get 4 equal pieces of data. There are the same amount of data points in each one. What do we use this for? To make a box and whisker plot. But let's fill this paragraph out. If 2 numbers are in the middle, you have to find the mean. You have to add them up and divide by 2. If the if the median is 2 numbers, those numbers belong to the upper and lower. So maybe you have 2 numbers just like this, they still belong. But if there's only 1 number, what is the word I'm looking for here? If there's only 1 number, it's your barrier. It's your boundary. You don't use it. It's not in the top half or the bottom half, so you don't use it. So if I had another number in here, say 36, then I would cross it out. I would not use that to determine my median of the lower half and upper half. I'm going to say disregard. Disregard it when finding, and I'll show you what that means, okay? Flip this over. We've got another example. Oh, maybe not quite yet. I will show you what that means in a minute. Okay, so this is 5 numbers. So besides the median and the first quartile and the lower quartile, we actually take the very, very smallest number and the very, very biggest number. That's pretty easy to do when you put it in order. And what we do is we make a box and whisker plot. And notice it says 25% of the data. So there's 25% of the numbers are between here, 25% or a fourth, right? Because 25% is 1/4, 1/4, 1/4, 1/4. The interquartile range, so range is always just the biggest minus the smallest. Interquartile range is the range between these two. Notice half, a fourth and a fourth, half of your data points are between there. Okay, so it divides it up and it shows you a lot of things. It shows you where everybody kind of lies and how it's pretty evenly distributed here on this one. So let's do another one over here on slide number 6. We've got temperatures. And guess what? This one is not in order. So let's put them in order. I got 1, 2, 3, 15 numbers. So I've got 68, right? Do we have any number 68? We've got a 69. We've got a 70. We've got a 71. We've got a couple 72s. 73. 74. We have 1, 2, 3, 4 75s. And 3 76s. And I'm out of room. Sorry, guys. 76, 76, 76. I apologize. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I hope you saw what I did there. I counted to make sure I have all 15 numbers. Because if I'm missing just one, it totally blows this up. All right? So 15 numbers. I know the middle of that is going to be my 8th number. 1, 2, 3, 4, 5, 6, 7, 8. 74 is my median, and because 74 is one of my numbers, it is neither in my it's not in my biggest or my top half or bottom half. It is in my boundary, so I don't use it when I'm finding my lower quartile median and my upper quartile median. Okay, write that down. I guess I could have written it down here. Sorry guys, again. Now here we go. 1, 2. The bottom half consists of 1, 2, 3, 4, 5, 6, 7 numbers. So my quartile 1 is here, and again 1, 2, 3, 4. Here's my quartile 3, and my minimum is just my smallest number, and my maximum is my largest number. So we're going to come down here. How do I draw a number line? Well, first of all, I have to have a number line that represents all of my data. So I go from 66 to 78. We're going to fit on here. My smallest number is 68. So I'm going to put my dot right up here, not on my number line, but above it. My largest number is 76. Okay. My quartiles are 71. I'm going to draw a line here because this is my box. That will be in the box and whisker plot. Then my upper quartile is 75. Now check this out. I'm also going to put a line on my median. So and then I'm going to draw the box portion. Notice it goes from quartile to quartile, and there's a line representing my median. And all I do is connect the whiskers to the ends of my box, and there you go. Box and whisker plot. Boom. Now this one looks a little bit different than that first one we had on slide number 5. In this one, we know that the top half right here, this is the top half of the numbers, they're all really close together. Look how small they are. They're all between 74 and 75. The bottom half, way more spread out, right? That's kind of interesting. All right. Now, you can probably figure out this one down here. It's just a small amount of numbers, so 5-number summary. It looks kind of funny. but we are going to do this for a couple days because there's a lot of calculating and there's a lot of little things you got to test and figure out on your own. We're going to start with a punchline worksheet, and then tomorrow we'll have our regular worksheet. Okay, if you have any questions, please come see me. Good luck.